Hello boys and girls, welcome to another episode of Volksbrouw. Finally today we arrive at part 2 of our Cytec MXS10 battery charger repair. The parts have finally arrived, so let's jump onto the bench, catch a quick recap and see where we left off, and we will take it from there. So of course here we are on the bench, and if we remember back to part 1, which I will link in at the end of this, these two N-channel MOSFETs, these 5R250P MOSFETs have given up the ghost, as well as these two 47 microfarad 400 volt capacitors. The MOSFETs went down in there, the two capacitors down in there. So of course I do have replacement capacitors. For the MOSFETs I don't have the same MOSFET. I have an F variant of the TK19A50W. In other words, it's a 19 amp 500, well it's actually 19 amp 500 volt MOSFET, N-channel MOSFET, where these are a little bit less than that. These 5R250s I think handle just over 6 amp. So what I'm going to do, I'm going to heat the soldering iron up, and then we'll come back with solder these new components in, and then we'll take it from there. Right, here we are back on the bench. Before we go on, I just want to talk a little bit about the package type. You see this metal tab, that is going to be common probably to your drain. So what they do, they have this mica or silicon pad washer behind it, but also what they do is they have this little bush that goes through and insulates the whole thing. Obviously with the package we're working with, the new variant doesn't have a metal back tab, so it's insulated, so I don't need to put the bushing guide or the mica pack back. So it's one thing to keep in mind. Also what they've done is, if you can see, pin 1, pin 2, pin 3, gate, drain, source, they've got a little ferrite bead here on the drain, just for noise suppression, EMI. So what I'm going to do, I'm going to take those EMI beads off, if I can. Well, of course it can, not so easy online. We'll take them off, we'll put them on the new MOSFETs, and we'll line the new MOSFETs up and put it in. One thing to be very aware of when you're doing, oh well, that didn't work. Looks like once these beads are on, that's it. Well, unless you go very gently. Okay. One thing to be very conscious of when you're doing this is the amount of silicon you're going to put on. So I'm going to just get a toothpick here. What I'm talking about is the your heat transfer compound, that white silicon rubbish that you want to put on the back. You really don't want to put a lot on. So I'm just going to move that out the way. We'll bring our new MOSFET in. And what I want to show you is you really want very little. If you put too much of this on, you're actually creating a heat insulator, not a conductor, which is what we want. So even that is a little bit too much. Let's put some on the next one. I did take it out, didn't I? Or didn't I? Yes, I did. Again, really don't want it spread on too thickly. Just a little bit. In fact, it's something you'll learn by feel, but too much can be detrimental. So just like that. And what we'll do is we'll line up our fets now. So I'm going to take these bushes off. We don't need them. We don't need the silicone pads. And all I'm going to do is I'm going to put it through like that. Put it through into the holes down there, push it through so it's aligned, and just lightly tighten it, just so it's holding. And I'll do that for both of them, then we'll come back and solder. Right, as we can see, I've put the two MOSFETs back. The lock nut, lock washer that goes behind it, the sort of spring washer, and then nut. Not too tight, so if we turn it around, there we can see our leads. So I'm going to try and solder this around the camera. Shouldn't be too difficult. All I'm doing, cleaning my tip off. I'm taking a little bit of solder flux from one side and heat from the other, and it really shouldn't be too much of a train smash. First one done. Second one. And that looks fine to me. Now I'm just cleaning my soldering iron tip off. We'll put a bit of solder on the tip because we're going to put it back in the holster. So now we're going to come back and do the two capacitors. So let's just cut that open. Now, of course, when you're testing capacitors, you cannot do this with a multimeter, and 99% of the time you cannot do it in circuit. You need to use a capacitance meter because capacitors are dependent on frequency, and they've been very kind to mark this. If you can see down there, that's got a plus. The capacitor's got two legs. The long leg is the plus, and the negative side of it is marked as with the negative stripping. And the capacitors I'm putting in Nichicon, so not too bad. So let's see if we put our capacitor. It looks like I might need to clean. Okay, not too, but we can see there's still a little bit of solder in there. So what I'm going to do is I'm going to take a bit of a solder flux, put it across each one. We'll take our heat braid, suck the old solder out. What you can notice on the board is it's quite dirty underneath. Not a train smash, we'll clean that up. A little bit of alcohol. Of course you want to use isopropyl alcohol, not just any rubbish. So where's my solder braid? Here we go. Clean the tip. And I just lock the focus there. All I'm doing, I put the braid down, put the tip over it, and let it suck it clean like that. Do the same to the next one. Of course, you don't want to hold it down too long, because you might lift the pad. Is that it? That's 3. 1, 2. Aha! That naughty one there. Still got a leg in. No problem, we'll take that leg out. Must be a leg that broke off the capacitor. Come on. Why push you through one of the two? There we go. Nice and clean. So we'll come, put our new capacitors in again. What we do with the capacitor, because it's a big one, just make sure we do one leg at a time so we can adjust it so it's sitting flush. Of course, these capacitors are quite big, so I would have to put some hot snot on it. So again, same thing. It's soldered. Just push it to make sure it's flush, and then we'll do the other leg. There we go. Nice. Okay, one more to go. And there she's in. And repeat the same thing again. Only one leg, then push it to make sure it's flush. Nice. Clean off your tip. Put a bit of solder flux on to coat it. And that's that. So what I'm going to do now, just going to cut off these excess leads. Don't cut it too close. And when you're cutting it, cut it at an angle. Just like that. And if you're a hobbyist or not, you might want to keep the excess leads. You always make good jumper wires in a pinch. Okay, now these ones, they don't need to be so deep. And of course these jumper wires do fly, so you might want to keep your finger over it. Right, all that's left now to do is clean the board. So of course, to clean the board, all I'm using is this isopropyl alcohol, and I just take a brush like that, dip it in, and wipe the board down, just like that. Give it a nice, good, clean. I want to obviously remove all the flux residue where we've been working. I want it to look crappy. And what you might find sometimes is after you've cleaned it with isopropyl, it becomes a bit tacky. That's not a problem. What you can then use is, I'm not telling you to use it, you can, at your own risk, is use some acetone with a cotton bud, or again with a brush. Okay. Right. All that's left for me to do is to solder back the power cord and the output cords. So I'm not going to do that online. You've seen how we solder. Same thing. Let me do that. We'll come back and we will put power on this board and see what it does. Right. Before I put power on this thing, I just decided to give it a quick little clean, and it was a good thing that I did that. So it seems as if we have bigger problems than what I surmised. I wonder if you can see that. So if you look there, that little transistor there, you can actually see the copper, the top end is blown out. These ones next to it are all pitted. These up here, and these up here in the right hand screen. So most of these transistors are all pitted. That means when whatever MOSFET went, it took these transistors out. So this poses a big problem for us. So what you can see, hopefully, if I just tilt it like this, these chips have been scrubbed. There's no markings on them. There's our little transistor that's buggered there. You can see that one's also taken a knock. This optocoupler also scrubbed. The CPU, the microcontroller, scrubbed. These two chips have got markings on. These two look scrubbed. So this creates a hell of a problem for us. Optocoupler not so much, that's easy enough. This I'm sure we can work out. There you can see the scrubbing if I turn it into the light. There you can see better. That one that's gone for a loop, that one that's taken another ding in it. You can see some of these up here, badly pitted. So I'm going to end this repair here. I'm going to speak to the owner and ask him if he wants me to go on. This resistor here shot as well. Well, it looks like it's either being scrubbed. I had a bit of damage. I'm going to have to speak to the owner if he wants me to carry on with this repair, because now it's getting beyond the realm of economical repair. Even though I'm not charging him for the repair costs, there's another one. But what I'm going to have to do is make a plea to you guys out there to share this video as far and wide as you can. So anyone that's got one of these and that can help me with some high-res photos of the board so that I can identify what these transistors are and what this chip is, so that I can replace them, so that we can keep this out the line full, that would be greatly appreciated, because it's just going to be too time consuming to try and work out what the heck these were. What I can say, probably all the low value resistances in this area are probably shot. I mean, that's the easy part. The low value resistors, probably some of these caps as well. Yeah, painful. But anyway, I'm going to appeal to you guys. Please share this. Please put it out there. If anyone's got one of these boards, whether it's scrapped, whether it's not, if you can make some high-res photos and send it to me, craig@folksbrow.com. I'd really appreciate that. So let's wind up this video. Alright, so we come to the end of another video. We'll call this one part 2 because I'm sure there's going to be a part 3. What a shoddy design. Anyway, I really need your guys' help. Anyone out there that's got one of these Cytec MXS 10 boards, whether it's shot or what, if you can make high-res pictures and send it to me. And ideally, if you've got the one where they haven't scrubbed the chips, that would be great. If you can share this as far as possible, I'd really appreciate that. Anything to get to find out what those components are, because I really don't want to spend the time reverse engineering it, and that's just too much of my time, and I don't think it's worth it. I will take it and show it to the owner and let him decide what he wants to do, but I think he's going to turf it. I don't really want to turf it because we are in South Africa. I mean, it's easy, you just throw it in a rubbish bag, but it's not the right thing to do. We want to keep it out of the landfill. So guys, please, if you can share this, or if you know somebody, or if you've got one of these boards and you can just take some high-res pictures of the back of the board, and it'd be great. Even if I get the transistor values for ICs, I'm sure we can work out. The optocoupler is not too difficult. I'd really appreciate it. Anyway, I hope you enjoyed this. I hope you had fun. And as always, take care. We'll catch you in the next one. Cheers.